Subdividing land isn't just about cutting lots. It's about understanding overlays, infrastructure triggers, access constraints, and council expectations before you lodge.
JCE's town planning and subdivision team looks at the whole picture: planning risk, service requirements, engineering constraints, and feasibility alignment. Not just approval, but approval that works commercially.
They don't chase fast DA outcomes. They protect your long-term margin.
If you're considering a subdivision or development application, start with clarity.
Head to jcengineers.com.au and explore the Town Planning Services page, because smart projects don't start with paperwork, they start with strategy.
Welcome back to another episode of So What Does That Mean? Today's episode is why cheap engineering is the most expensive decision you'll ever make.
If someone offered to design your project for 30% less, would you take it? Be honest. Most people do. And most regret it later. Because here's the uncomfortable truth. In construction, the cheapest decision up front is usually the most expensive decision long term.
And it doesn't feel risky at the time. It feels smart. It feels commercially responsible. It feels like you're protecting the margin. So, Brendan, why is it that smart business people still fall into this trap?
Because we're conditioned to compare numbers. 28,000 versus 19,000. That's a $9,000 saving. And on paper, that feels like a win. But engineering isn't a commodity. It's risk management. And when you reduce the fee, you are reducing something. Question is, what are you reducing?
Let's ground this into reality. Rectification costs are typically 4 to 6 times the original design fee. Mid-construction redesign, 25 to 100 grand plus. Around 60% of structural disputes originate from documentation deficiencies. And here's the one that always shocks people. Saving $8,000 upfront can actually cost you $80,000 later.
And that's not exaggerated. That's conservative, because rectification doesn't mean redesign. That means demolition. It means rework, program delays, legal advice, consultant coordination, client frustrations. Cheap decisions ripple, and construction multiplies mistakes.
So is the real cost of cheap engineering the design itself or the downstream impact?
Always downstream. The design fee is tiny compared to the build cost. Engineering might be 1 or 2% of total construction costs, but it controls 100% of the structural risk. Think about it. You're protecting millions of dollars by negotiating thousands. That's misaligned thinking. Let's break this down properly. 2 engineering quotes. You've got, say, quote A, 28 grand, and you've got quote B for exactly the same services, inclusions, exclusions, assumptions, and it's 19,000. So that's 9 grand cheaper than quote A. Most people compare the number. Almost nobody compares how many hours are being allocated. Is there senior oversight? How long are they going to spend on the project? Design review process. Is there a design review process? Is it collaborative? Do you get your input into the design process as well? Are site inspections included? Optimization effort? Documentation quality? Insurance coverage? What's actually excluded? What happens if you go through with, quote B, 19 grand, and then you go, hang on, it doesn't include a flood report, or it doesn't include site inspections, or it doesn't include compliance certification. And then you find out after the fact that you actually spent more than quote A of 28,000 once you included all of the same services. Cheap is not a discount. It's a reduction in something.
So let's unpack that. When a consultant charges less, what are they usually reducing?
Typically, it's one of 5 things: time spent on modeling and checking, senior engineer involvement, peer review or internal QAs, site inspections. If you don't have to go to site, you don't have to commute there, you don't have to spend the time to get there, then that's gonna give you a saving. And then your optimization effort. And every one of those has consequences.
Can you explain the hours point? Because clients never see that.
Yeah, exactly. A $28,000 fee, we might allocate 120 work hours. And a $19,000 fee might be allocated 70 work hours. It's not efficiency. That's 50 fewer hours of thinking, checking, coordinating. At the end of the day, engineering is cognitive labor. You're paying for the thinking time. And whose thinking time? Are you paying for a junior's thinking time? Are you paying for a senior's thinking time? What happens if the result that you get doesn't satisfy you or doesn't provide the results that you need? Who are you then going to go back and ask the question of? And who's going to then respond with what you need? Reducing the hours means that you're actually reducing the thinking time.
Well, what about experience?
Huge factor. Cheap fees often mean graduate-heavy design, minimal senior review, and fast turnaround pressure. Experience isn't expensive because of ego. It's expensive because it prevents mistakes before they...
And what about your QA process?
This is where things quietly unravel. Good firms have structured internal reviews. They do peer reviews, they have peer checks internally, design validation, optimization. Like, how do we know that your design is the safest? How do you know that your design is the most optimal for what it is that you want to do constructability wise, and meeting your objectives? You need the best way to do that is to get another set of eyes on it. If you have the same person that's looking at that same design that's spent a week developing it, they're going to be subjective in their review. Undertaking a low case review, cheap firms skip these steps. Not because they're reckless, because they can't afford to spend the time. And construction punishes skip steps.
So what does this mean for consequences? Like, how do we see this later down the line?
Yeah, I mean, delays is a big one. Poor documentation creates RFIs.
What's an RFI for those at home?
Request for information. And it should, because if you're producing poor documentation that comes out and doesn't answer the queries or doesn't provide enough information to proceed to the next step, then it is poor documentation and you should be raising a request for information. RFIs slow projects. Every single RFI has to stop the progress of whatever is happening. You need to now create a bunch of email chains to go back and forwards with either the designer, the consultant, the builder, the asset owner, the subcontractor, the surveyor, the saw tester, whatever that might be. You've now got to go through and ask one question or 5 questions of everybody else. And you've now got to arrive at one single direction to be able to then give the person on site that direction and allow them to move forward. But as we've discussed previously, delays cost money. They add frustration. It burns that site time. And one stalled week on a medium project can exceed the original engineering savings.
So you're saying you saved 9,000, but you could essentially lose 30,000 in program delays. That is absolutely not a win. Let's talk about relationships. What happens when drawings are incomplete?
Well, I mean, if drawings are incomplete, they go back to you. You take it to your builder, your contractor, whoever that might be, and they're going to protect themselves. I mean, naturally, that's what they do. The first thing they're going to do is they're going to blame the inaccuracy of the drawings. By the time they get it, they're at the end of the design and the planning process. They're now looking at how can we practically make this work? How can we bring this to life and develop your project? For them to have a good reputation with you from the start of their engagement, they need to set your expectations at a certain level. So straight away, they're going to look at the drawings and they're going to go, hey, there's issues here. They're not clear because they didn't develop the drawings. Somebody else developed the drawings and they've got a particular way that they like to do things. So obviously the drawings are not going to match exactly that. Um, some builders and contractors actually take care of the design themselves and direct the design themselves and hire an external consultant to do that and, control that decision making. And in my view, they're the ones who come back with the best design, with that construction experience applied early onset in the planning and the design phase. If documentation lacks clarity, builders and contractors will just identify variations to be able to, charge later on if they need to, or through the process if they're already there, they will hold things up and they'll go, hey, there's a variation here, and there's a variation because of this. The rock clause is a perfect one. The rock clause is something that protects the builder and the contractor, and every single builder and contractor should have this. Don't get me wrong. They don't know what's below the ground, but if they start digging in the ground and they find that the soil or the ground in that particular location is harder than what they've assumed to dig through, and all of a sudden they find some volcanic bloody rock layer that they can't actually dig through, then that's going to be an issue, right? So if they don't know, and if your soil tests and your drawings don't identify that there's a rock layer there, then they're going to issue a variation. They're going to issue a variation. Generally, a rock clause is a dollar per rate of trying to break that rock up, and it's up to them to determine whether it's rock or not. How do you know it's rock? Rock is defined by how solid it is.
Mm.
I've had so many people go, oh, well, the ground's hard, so it's rock. It may not be rock. It may be something else that appears like rock, but it may not actually be rock. If the documentation lacks clarity, they also push back on responsibility. They try to disassociate themselves from it. They request written clarification, which 100% they should be doing to cover themselves. And they delay making decisions. They procrastinate. It goes to the too hard basket because they're also under time pressure to be able to get a result, pay their wages, pay their bills, and operate their business. Because their risk increases, cheap documentation shifts risk onto others. And people don't accept risk for free.
So another interesting one here. Cheap doesn't always mean underdesigned, does it?
Correct. Sometimes cheap means rushed design, which can lead to overdesign, excessive steel, excessive cost, or underdesign, compliance risk. Optimization takes time. Time costs money. If optimization isn't included, you might pay more in materials than you saved in fees.
What about insurance and liability? Let's touch on insurance because people rarely think about this.
Yeah, and professional indemnity claims in construction are rising. I know because my fees keep going up. Insurers now scrutinize underscoped work. Some low-fee consultants carry lower insurance limits. And if you go to your insurance company and you reduce your professional indemnity limit from 10 million down to 5, it's obviously a cheaper premium to do so. Or you can exclude certain things from your scope. You can exclude, say, I don't know, fire engineering, for example, if it was just something we didn't do. So anything associated with that to determine what your engineering insurance fee would be, obviously then reduces when you exclude that from your scope of insurance or scope of coverage. If something goes wrong, your exposure increases. Cheap consultants can mean cheap coverage, and that becomes your risk.
So what's the psychology behind choosing cheap? Why do experienced developers still choose the cheapest quote?
3 psychological reasons. Anchoring bias. The lower number feels like the smart deal. Overconfidence bias. We've done this before. We'll manage it. Short-term margin focus. Immediate savings feel tangible. Future risk feels abstract. Humans discount future pain. Construction does not. For accepting the cheapest fee, ask, how many hours are allocated? Who is actually designing it? Is senior review included? Can I see their CV? Is optimization included? Are site inspectors included? If site inspections aren't included, how are you going to grab the information you need to be able to determine the result? What is explicitly excluded? What level of insurance is carried?
And here's the key shift. Stop asking, how can we reduce the fee? And start asking, how can we reduce the risk?
Because the cheapest consultant is often the most expensive decision.
If this episode made you rethink how you evaluate consultants, that's the point. Engineering is not a line item. It's a risk control system.
Price is what you pay. Risk is what you carry. And if this episode saved you from one bad decision, make sure you subscribe on YouTube, follow us on Spotify, share this with a developer, builder, or project manager who needs to hear it. Because in construction, the real cost isn't the fee. It's the consequences. We'll see you next week.